very good day to all the panelists. My name is Yip Siew Ling. My Matric number is B051710190. Today, I would like to present about my final year project 1. The title name is Optimizing Anaerobic Digestion of Biogas Productions from the Commercial Food Waste Source for Green Energy Generations. Let's start with the introductions. Popular of Malaysia is expected to reach 33.4 million by year of 2020 and 37.4 million by the year of 2030. The energy demands, on the other hand, is predicted to increase by 4.7% annually, where the electricity consumption having an annual growth rate of 8.1%. Biogas is important as it can offer a win-win situation towards a nation effort to achieve energy security while combating waste accumulations. Biogas is the product from anaerobic digestion of organic waste where it can be utilized to generate electricity. The major source for biogas in Malaysia are palm oil mill effluent, pomade, livestock manure, and also municipal solid waste. So this is basically the biogas cycle, the figure. What we can see here is the input is the organic waste, then the process occur is anaerobic digestion, and generate the output is the biogas, which can be used as the electricity and also thermal energy. For the problem statement, the commercial food waste has led to significant global issues such as environment impacts and also economy loss. Addressing these issues will have practical benefit for whole country toward renewable energy productions, as well as toward a better waste management practice. This project aims to optimize anaerobic digestion by converting food waste into biogas productions as source of renewable energies. So the project scope, what we can see for the area for this project, based in the resident area in Taman Tasik Utama in Malacca. This project is aimed to generate biogas as the green energy. For the performance of biogas is going to be measured by water displacement method and also gas chromatographic analysis. For the factor involved in starting a project is because I've gained my interest in related topic as involved in the green sector within my internship period on the July 2020. For this project goals, is produce biogas with maximum presence of methane gas as a source of renewable energies. For this project time frame, what we can see here, the starter line is 30 October 2020 to 30 November 2020. Within this period, okay, I will conduct about my chapter 1 and chapter 2 for this project is introduction and also literature review. So this project is started with title name and follow with introduction, objective, and literature review. Next, within the period of 1 December 2020 to 18 January 2021, I will proceed to chapter 3, which is methodology. Methodology is planned based on previous chapter, introduction and literature review. The submission of video and report of FYP1 will be submitted in these periods. So for the next period, I will proceed into chapter 4, which is result and also discussion. In this project, the commercial food waste I have chosen is chicken leftover. So this chicken leftover management will be conducted and also followed by characterization with FTIR and also TGA method within the period of February 2021 to March 2021. So next, for the period of March 2021 to May 2021, I also continue proceeding chapter 4, which is result discussion. The digester reactor will be set up and design of experiments will be conducted based on 3 factors stated in this case. The testing stage of H2S, hydrogen sulfide, plus CH4, methane quantification will be carried out within these periods. So lastly is the chapter 5, which is the conclusion, okay, will be conducted within the period of May of 2021 to July of 2021. So within this period, conclusion will be drawn based on objective as stated. Suggestion for future will be carried out in the end also. Okay, next, I will explain about the objective. The first objective is based on the input, which is to characterize the specific food waste, chicken leftover, in terms of their composition using Fourier transform infrared FTIR analysis and thermal gravimetric TGA analysis. So for the second objective, which is based on the variables, is to evaluate the effect of pH, digestion times, and feedstock ratio during anaerobic digestion toward the methane and hydrogen sulfide yield. For the third objective, is based on the output, is to optimize methane yield with minimum presence of hydrogen sulfide for biogas production. Review. So for the first chapter, the subtopic is the commercial food waste. I will basically explain about the definition of commercial food waste, source for the food waste, and also impact of current situation, which is MCO, Movement Control Order in Malaysia, towards food waste generations. The second subtopic is anaerobic digestion. In this subtopic, I will briefly discuss about the anaerobic digestion stages and also quantitative evaluation of anaerobic digestion, and also the factors that lead to process failure in anaerobic digestion system. For the third subtopic, I will discuss about the biogas generations. In this subtopic, I will briefly explain about the biochemical reactions that occur in the biogas, feedstock characteristics, livestock populations, and also the potential of biogas generations. For the fourth subtopic, I will basically explain about the green energy generations. So in this topic, I will discuss focus only on the total energy consumption in Malaysia. So for the last subtopic, I will explain and discuss about the previous study related with optimizing. There is three aspects I will discuss, which is extraction, volatile fatty acid, optimum condition for production of biohydrogen, and also optimizing methane productions. Next, I will explain about the methodologies. This is the overall flowchart of the methodologies. So for the starter point, okay, I will do basically collect for the food waste, which is the chicken leftover, okay, at the resident area in Taman Tasik Utama, Melaka. Okay, next I will proceed for the cleaning and drying method for the food waste. Then next I will do and conduct about the food waste characterization using the FTIR and also bomb calorimeter and also TGA analysis. Okay, then for next I will do about the digester reactor design. Next is the design of experiment using two-level full factor. Next, I will basically conduct about a testing stage for hydrogen sulfide and also methane quantifications. Next, I will do about the optimization and validations. And next, result and discussion, and then is end. When it is touchwood unsuccessful, I will return back from the full weight characterization using FTIR and boom calorimeter to start back. Then for testing stage of the methane gas and also hydrogen sulfide gas, if unsuccessful, I will return back to the digester reactor design again. And then next, for the optimization and validation, if it is unsuccessful, I will return back to the design of experiment DOE using two-level full factorials. For the methodology, I also set based on the objectives stated. For the first objective, to characterize the specific food waste chicken leftover in terms of their composition using FTIR analysis and bone calorific test. For the food waste collection, I will do based on three options, which is door-to-door, curbside, alley, or backyard. Collect through these three methods. Okay. Then for the food waste cleaning method, I will clean through rinsing method, and also for the drying method, I will dry based on four methods, which is bio drying, biostabilization, solar drying, thermal drying. For next, the food waste characterization, which is FTIR and also TGA analysis. Basically, FTIR is used to detect the functional group and gaseous product of volatile to determine the pyrolysis mechanism during different reaction process. For TGA analysis, is to estimate energy content of substrate. Then next, we will proceed to the second objective. Second objective, which is to evaluate the effect of pH, digestion time, and feedstock ratio during anaerobic digestion towards the methane and hydrogen sulfide yield. For the digestion, for the digester reactor design, I've used 5 liter empty PVC can, okay, will be used as the digester tank. And also PVC pipe and valve will be connected to inlet as feeding substrate, one outlet as delivery system, and also one outlet as the waste outlet. Okay. For the DOE, which is design of experiment using two level of full factorial method, how it basically roughly be, the procedure is I have to insert the minus, which is low level, and also plus the high level for 3 factor, and also the factorial design is approximately 8 runs, which is in the form of cube. Okay, then 2-level full factorial method will generate out the statistical ANOVA based on 3 factors stated in this case, which is pH value, digestion time, digester time, and also feedstock value. Lastly is the testing stage for hydrogen sulfide gases and also methane gases. In this testing stage, I will use water displacement system and also large string at interval, okay, to measure the volume of biogas. Next is the gas chromatography analysis is used to measure the gas concentration. And then next, we will proceed to optimization and validation. So this circle picture is roughly the picture of the digester tank. I will roughly discuss about my problem faced in when complete this final year project one. Okay, but the problem I face is the instrument issues. I have made some issue which is price and the condition for the instrument. About the GC-TCD chromography, thermal conductivity detector is considered very pricey lah, it's expensive. So I've made a decision of lend this GC-TCD from UPM to identify the composition of biogas. It's relatively more affordable lah, the price. Then for identify the volume content of biogas, I have used the water displacement method to identify them. It is considered much more simple and also inexpensive. Then for the biogas content, I will fill it into whether these three options, which is biogas bag, fishbowl, and also Tesla bag. Also face the issue of how to collect and where to collect the inoculum. Okay, basically an inoculum is to speed up the anaerobic digestion. Okay, for make them the successful rate is more higher. Right? This collect issue I've discussed with my industrial supervisor. Luckily, she can sponsor me some inoculum plus the inoculum. The inoculum is basically to providing the abundant bacteria that needed, okay, for converting substrate to usable methane CH4 gas. For watching.